Me and Casper feel the same right now.
Anyway, Justin is still with us. Justin, oh my goodness, that was so much fun.
I had a blast.
Yeah, I'm glad you enjoyed it, because that was one of the favorite interviews I've ever done. Your daughter is amazing. I feel like...
Yeah, I got a message from our engineering office saying that they had this on the big screen, and that my daughter's antics had the whole room rolling.
It was happening here too. Everybody was laughing, and I was like trying so hard to keep my composure. There was a few times I lost it, but it was usually when there was like an image on the screen or we were playing a video or something. But oh man, I was like, okay, I need to like stay focused, but also this is amazing, but also like, quick, what's the next question? It was really cool. So.
Good job to both of you for keeping composure, and I like how we even got to ask her a question too.
Yeah,
that was great.
Super cool. I think there's actually a whole bunch of questions that I didn't get a chance to ask in the chat room because we kind of like we jump between topics, and so I didn't want to like go back and start talking about the other thing again. So let me see what I got here. But people were
I have a question about the recycler, if I may.
Yeah, go for it, Mike.
How does that system work? Are you guys like melting down the waste material and re-spooling it? How does that work?
Yeah, more or less. What we do is we've got a feed system that breaks down whatever's fed into it into essentially a uniform particle size, and then we remelt it down and extrude it into filament.
Okay,
That's
easy,
awesome.
Nice.
We've got a question from Smokey Dog in the chat room here. And Smokey Dog asks, 3D printing on Earth often requires that the object being manufactured has supports built into the design. Is that not required on orbit since it's a weightless environment?
Correct. We design everything so that we don't have to use supports, in part because that's wasted material, and in part because they don't have to hold their own weight. So we're done.
That's awesome. Also, hi Vax, how you doing?
Hey, it's awesome.
We have Vax is with us, Emery Stagmer, for those people that don't know Vax's actual name. Vax was on the show last week. Yeah, it's nice to have this continuity of people on the show.
And hi to Justin. Nice to see you. Awesome interview, and kudos to both you, Justin, and Lisa for keeping their composure. It was so cute.
It was so adorable.
It was hilarious.
Oh my goodness.
Wow.
Vax, did you have any questions you wanted to ask Justin?
I need to recuse myself because I'm currently working on the Northrop Grumman part of the program with Made in Space.
Never mind.
I need to
It's fun because the chat room has lots. So I've got Hanny's Warweb on Twitch that wants to know what's the strength of the objects that can be made presently, and how strong can the prints get?
No, that's a great question. So a lot of the work that we did with NASA Marshall was the material characterization of the prints that came out. And we actually did a couple hundred prints through that experiment program, both on the test printer and continuing on the AMF. And we've found that the bulk properties of the finished parts are actually about the same as the bulk material on the ground. So, anything that we print out of ABS has the same strength properties as, like an injection molded ABS part. The same for HDPE and Ultem. Where it'll start to get more interesting, I think, is when we start looking more at things like metals, resin parts, things like that. That's really a new frontier for us, so we haven't fully characterized that yet. But one of the things that I think is really interesting about our additive extended structure manufacturing process for Archinaut is that we can actually change the cross-section of the parts as they're manufactured so that you can actually have a variable geometry shape that is optimized for whatever vibrational modes or loading that you expect to have on the structure while it's in space. So you can actually use the shape to control its strength and mitigate any issues that you might have from the material itself.
That's so cool. Oh man, it's just so customizable. That's opens up so many opportunities. Wow.
So, Justin, two of the kind of the key things that I've heard people talk about, and that I've heard from being able to manufacture things in space are, number one, you can build things larger than you can launch, and also that you can build things more delicate than you can launch, because launch is pretty harsh. Is there any other really obvious benefits to those to being able to do that? Obviously, you can build things that you didn't know that you needed, right?
Right.
Yeah. So you don't have to actually launch the actual object. You can just launch the bulk materials in order to make the object.
We're finding that there are two things that most people are interested in. You know, from the NASA side of the house, they're really interested in what we can do to reduce the amount of mass that you have to carry with you, because mass is money, mass is volume, mass is everything. Especially when you're talking about long duration missions, where right now you have to carry everything that you can foresee with you. And one of our interns did a demo to see like how fast they could solve the Apollo 13 problem if they'd had a 3D printer in the limb. And they were able to solve that problem in less than an hour by printing the adapters that they needed, rather than having to go through that crazy jury rig contraption that they ended up coming up with. We also kind of wisecracked that, The Martian would have been a very different movie if Mark Watney had had a 3D printer.
Which he should have, right? Because it's that far enough in the future, right?
He should have.
That was stupid.
Right.
Yeah.
And so, having that ability to both reduce the total amount of bulk mass that you have to carry with you, and the ability to quickly respond to kind of your unknown unknowns when you get there is really important. And then for people that are interested in manufacturing for satellites, there's a lot that we can do to make space systems much more efficient and much more effective. So, for example, with the Archnaut system, we have found that you can put a set of solar array wings that are manufactured and installed by Archnaut that are up to 10 times bigger than what you can carry with kind of your standard body-mounted arrays, or even body-mounted deployable solar cells. And that's huge, because you look at what the Department of Defense wants to do with having wider distributed networks of smaller, less expensive satellites, because right now, they fly these multiple hundreds of millions of dollar satellites that end up being really big targets, and they're trying to get away. You have the revolution going on right now with installations really starting to come into that wasn't technically or financially feasible 20 years ago. Well, imagine what we can do if we can outfit these 100 to 300 kilogram satellites with multiple kilowatts of power. That enables them to do much higher broadband radio signals, that enables them to do onboard data processing in a way that they're power limited by now. And so I think even more so than what we're doing to help with space exploration, this industrialization of low Earth orbit is where you're going to see a lot of the opportunities grow.
Yeah, we talked a little bit about that. You and the lights. They talked a little bit about that last week. Yeah,
making your own solar panels too. Holy cow! Real quick, I'm sorry, guys. I do have to go. This is so fascinating. I'm going to catch up on this later. But this was such a great show. Thank you so much for joining us, Justin. Thank you so much for being here, Vax. Oh man, this is so exciting. But I will have to catch you guys later, though. Thank you. This is a great show, everybody. Good job.
Bye, Space Mike.
See you, Mike.
Yeah, wow. Just the fact that you can make solar arrays so much bigger now. I mean, you're right. So many applications right now are limited up there because of power requirements. And so if you're able to now have 3 times more power, 5 times, 10 times more power available to you on orbit, like, now what do you do with it, right? It opens up so many new opportunities.
Well, and there are people that already have ideas for what they can do. We just got to prove it out on orbit first, and that's the next big step for us.
Is that how we accelerate space-based power generation? Like, I feel like we had someone on the show before that like they took solar power like from satellites on orbit and then they microwave beamed it down to Earth, and then like that was like a green power alternative. I might be pulling something out of thin air here.
No, people have been talking about doing that for 50 years.
Whoa.
And we haven't had the orbital infrastructure or the launch vehicles or the high enough efficiency in the electronics to be able to do that. All of those things are getting to the point where they might actually be possible. 5 years ago, people were talking about, orbital power beaming power back to Earth. And I would look at them and go, the electronics just aren't there.
Yep.
You're going to lose so much efficiency and heat. You've got, the end-to-end of the solar power coming in to the microwave power going out of just the satellite. Those efficiencies were on the order of 20%,
right.
End-to-end, right? That means 80% of what you're getting in, you have to reject as heat somehow, and the mass that you had to launch in order to have just the heat radiators, it didn't make any sense.
Yep.
Those things are getting to the point now where those efficiencies are much, much higher than that. And so we can start to talk about, I think, being able to do that without having to get rid of megawatts of heat or even hundreds of thousands of watts of heat.
That's awesome. That's so cool. Oh, man.
Johnny Boy had a question. Can we push that up here? Any plans to 3D print CubeSats?
I was listening to the earlier conversation about swarms of CubeSats and all that. We actually did a demo on a parabolic flight where we printed a chipset and essentially replicated both the functionality of Sputnik and, if I remember correctly, our chief engineer programmed it to play the OSU fight song because he's an Ohio State grad. And so the technology is definitely on its way. We actually have the ability to print CubeSat structures on the space station right now. And then, if somebody wanted to fly an electronics package, that would then plug into that microgravity optimized structure and then put it in like the NanoRacks deployer or the Japanese small satellite deployer. We have the technical capability to do that today. And once we get this, electronics manufacturing package really optimized and operational, you combine that with our structural manufacturing capability, and then, you really do have the ability to print an entire CubeSat on orbit. So that'll be definitely in the realm of the possible within the next couple of years.
I'm excited for that. It's like you don't even need to do anything on Earth. Just like you're on the station, you're all set. Let's make a CubeSat. Let's send it out, and you're done. Oh, that's the dream.
Yeah, we had an idea for a NIAC project with NASA Ames a while back, where we kind of looked at the idea of if a seed craft was sent to Alpha Centauri, and then when it gets there, we have a manufacturing machine that builds whatever CubeSats or probes you need, so they don't have to try to survive the journey. You just send a seed craft that's very heavily shielded with a bunch of feedstock and a handful of manufacturing machines, and then you build what you need, whether it's an ultra large antenna to send data back to Earth, or probes and satellites. You build all that when you get there, rather than try to carry it all with you.
We need that on Mars. We need to send a manufacturing ship to Mars and make a giant antenna so that we can send more stuff back. That would be cool. I would like that a lot.
Yeah, big RF antennas are one of the really kind of the low-hanging fruit almost. If you can build an antenna that can send back, it could be a football field sized kind of thing, and
yes,
allows you to have a way higher bandwidth sending back from those kinds of distances. Yeah, it'd be a big deal. Very big deal.
Yeah. Very big deal. We're looking into structures like that, both large flat reflect array panels, because those are more conducive towards robotic assembly, just because it's something that you can essentially stack them in a carrying case and then unfold them and weld them together on orbit. And then for large reflector antennas, we're developing the capability to build, sub-millimeter precision structures so that you can put those, high quality reflectors on a very large. We're talking like 40 to 100 meter diameter structural spars where you can stretch out these RF reflective materials.
Has your daughter there?
Is that an Atlas 5?
She's got an Atlas.
Is that? Oh my God! I want that toy.
It's so cute.
I want one. Where do you get them from?
I have friends at ULA.
They're available on the ULA website, shop.ula.com or something.
Shop.ula.com.
Excuse me while I just buy one. Seriously, it's adorable. Oh man.
Yeah, her dad is an aerospace engineer and her mom is a doctor. So we've long resigned that our children have no hope of a normal childhood.
ULAlaunchstore.com.
Activate launch sequence in 1, 2, 3, 4, 5. Blast off!
Yay! Where did your rocket go? Did it go like to the moon or to Mars or somewhere else?
Where are you sending your rocket, Ellie?
To moon, to moon.
She says
She's
to the
moon first.
Moon first, yeah.
Oh man. Justin, we usually ask all our guests like 4 general questions just about spaceflight in general. I didn't ask you them because due to time
Why
and
is
stuff.
there 3 boosters on this
You should
side,
ask
but
Ellie.
only 2 on that side?
That's just the way it's built,
Oh,
sweetie.
because that's the 5-1 configuration.
Yep.
You lost a wing. Oh man, now we're gonna crash into the loops.
That's exactly.
We know how to do that.
Wow.
This is the best show ever. Okay.
I say, sweetie, you see the man on the other side of the camera there?
Mm-hmm.
He worked on the mission where they actually crashed part of the upper stage of one of those on the moon
Oh.
on purpose.
On purpose. Yeah. And found water.
Yeah, they found water.
This show
That's when they
keeps
found water.
Yeah.
going like throwing back into each other. This is just showception.
Okay.
So we have 4 questions, but let's
where's
get
your other one,
answers
sweetie?
from the both of you if you want. I'm very curious to hear both your answers.
Yeah, I have a gray one.
Sure.
I have
So
a gray one, right?
Mm-hmm.
One of them is gray, one of them is yellow, one of them is orange.
Yeah. Where's your yellow one?
the first question is, what is your favorite space mission of all time? It can be past, it can be in the future.
Oh, favorite space mission. That's a tough call. I guess I almost feel like I have to differentiate between the favorite space mission in fiction and favorite space mission in the real world.
Go for it.
Favorite space mission in fiction is definitely the Discovery mission in 2001: Space Odyssey. I saw that movie when I was a kid, and just the themes and the visualization, all that just grabbed me from the time I was little, and that's, I guess, in some ways still the world that we're trying to create and that I'm trying to create at Made in Space. Favorite space mission in reality, I would say would have to be because now we're talking about human versus robotic.
That's a different question.
That is actually legitimately different
if I have to pick one, I would say that it is still Voyager 2, because that was the first mission where we got to see the outer planets, with our own eyes and in detail. And when I was a kid, I actually had a super HD or super VHS video of the Grand Tour, and it used all the latest imagery that they had from Voyager at the time. And again, that was just something that captivated my imagination. And and that's something I'm actually grateful about being at Made in Space now, is because these are platform technologies. We're getting to build things that go help astronauts on the space station and on future missions. We're developing the technologies to build ultra large antennas for both commercial satellites and deep space missions. So we get to do a little bit of everything, and that's really exciting.
Wow, that's so cool. You led very well into our next question, which is human or robotic exploration of the cosmos?
It's both. It has to be both. We send people out where we can to expand our sphere of influence and expand the nature of the human condition. And I am of the philosophical school that believes that humans need a great big challenge to continue our evolution and push us to be better and do better. And space is that next frontier. But we also can't afford to send lots of people everywhere, at least not yet. And so we need robots to push those boundaries back, go where it's either not yet safe or not yet established for people to go. And as robotics continues to advance and continues to evolve, we're going to have people and robots working hand in glove. We have to, I think, to establish settlements in a sustainable way, just because we have thousands of years of civilization underpinning everything we do on the earth today, whether it's the sanitation running under my house to the airplanes flying over my head and everything in between. And we won't have that with us when we go to these other places. So we've got to figure out ways to sustainably and reliably incorporate automation, robotics, machine learning, and human ingenuity and intuition so that we can sustainably explore other worlds. I don't believe that there should be a dichotomy between the two.
Wow.
Dennis Wingo, who we've had on the show before, described robots as being a force multiplier for humans in space.
Yes.
I thought it was a really
I agree with
good
Dennis 100% there.
Wow. Our next question is, where should we explore next?
So this is when I'm really going to sound like an engineer. I am a systems engineer by training and background, and I actually don't think any particular destination is as important as why we're doing it. Because answering the question why, that's what drives architectures. That's what drives how we build programs and how we build systems. So I'm more interested in why are we going and what are we trying to accomplish. So if say for example we decided that the reason why we're going back to the moon is because we want to build a big radio astronomy telescope and science center on the far side of the moon because it's a great place to do radio astronomy, then I'd be 100% behind that because there's a science need. It drives new technology. It'll drive new innovation. There are roles for both humans and robots in implementing such a program. If that's what we're going to do, then, let's do that. And if we're going to go to Mars, we have to decide: are we going there solely to look for signs of life? In which case, then maybe that means we do build a system where we're doing telerobotics from base camps on the surfaces of Phobos and Deimos, rather than putting human boots on the ground because of planetary protection protocols. But if we're going for the purpose of settlement and expanding our civilization, then that does drive a different architecture, and we have to focus on solving the problems of how do you put large, heavy masses on the Martian surface safely in a way that we don't know how to do yet. And so I think figuring out the why and articulating the value proposition to human society for why we do these things and why we go to these different destinations, that's much more interesting to me than just picking any one particular place. But if I did have to pick one particular place, it would probably be Jupiter, because I read Arthur C. Clarke's A Meeting with Medusa when I was in elementary school, and the way he described Io and Europa and the clouds on Jupiter, I will remember that story probably until the day I die. And there is a kind of base primal part of my brain that would just love to be able to see that with my own eyes one day.
I don't think we've ever had anybody answer Jupiter before. that's very
Yeah.
cool, and I love the reason. That's fantastic.
Super unique. That's amazing. You pretty much already kind of bled into the next question, which was awesome. But our final question is why space?
So I think, there are all kinds of different reasons why, we go to space. We go to space because it's now part of our economic sphere through telecommunications, position navigation, and timing. All of that infrastructure is a part of our economy in a way that's frankly transparent to most people. And I think, like, most people don't even realize that the banking industry, as we know it today, relies on GPS timing to such a degree that if the GPS system, like global GPS, whether it's GPS, Beidou, Galileo, I forget the name of the Russian one offhand right now, but if all of those were taken out, global banking would come to a halt. And I think people probably ought to appreciate that more than they do. But anyways, there are economic reasons to go to space. There are scientific reasons to go to space. There's the long-term view that eventually the sun is going to expand into a supergiant state, and we're not going to have a home anymore if we don't figure out how to get off this rock. But in the nearer term, in the present, I think it's important to recognize that we look at what's happening in the planet today. We look at what's happening with what we're doing to our ecology and to our planet. We're conducting a really big experiment right now, and we don't know how that's going to work out for humanity and for civilization. But we know up in space there are more useful resources than have ever been extracted in the entire history of humanity. And we can go extract those resources and put them to use and elevate the standard of living for everyone on the planet without having to destroy our ecosystem and our biosphere to do so. So, ultimately, that's really the big reason why I'm at Made in Space, is because moving that industry and moving that methods of production into space is a critical part of really being able to bring space into our economic and social sphere in a way that we don't currently do. And I think that's the key to actually, eventually building a kind of society where scarcity is a thing of the past, where energy is so plentiful that it's effectively free. And what we call rare earth metals today, they're not rare, and they're common, they're plentiful. Imagine how different our electronics would be if those materials that are so expensive and so toxic to extract from the earth today were as plentiful as aluminum and steel. And so I'm excited to build the industry and build the infrastructure to make that happen and really elevate society for everybody.
That was an incredible answer, Justin. Your passion for enabling space to become enabling humans to become a spacefaring civilization is it's so apparent. That was our final question, and I think we're probably going to wrap it up because not only am I hungry, but our Zoom meeting with you it's on a timer, so it's going to time out really soon. I wish I could keep talking to you all day because this is incredible. But I just wanted to say a big thank you again for taking time out of your Saturday, for having your daughter join us on the show. That was absolutely adorable, and it's really been a blast, and I'm really, really glad that you could come and share your story with us today.
Thank you for having me. I enjoyed it.
Awesome.
Good to see you again.
All right. Well, we're
Good to
going
see
to
you,
go.
Emery.
We're going to go, Internet. So thanks for watching After Dark. This will be posted in approximately 3-4 weeks, whenever Ben feels like it. I don't know. And you can always get access to After Dark early by becoming a patron. So thank you so much, and we'll see you next time. Bye.